So like, is that my answer? No. You need to do the whole thing. No, because look. See, what we do in our friends.
Okay, girls. 3 part 6. Right, is the integral of 1 all over x squared minus x all over the square root of x times dx. Okay, thank you for not talking while I am. Right, that's the integral of, this is x to the power minus 2. Right, when you bring it up. Here, this is x to the power of 1 divided by x to the power of a half, isn't it? And the rules of indices say top take away bottom. So that would be x to the power of minus, it wouldn't be, it would be plus a half, wouldn't it? 1 take away a half. As in the square root of x can be written as x to the power of a half, and then top take away bottom, that's 1 take away a half, which is a half. Is that alright? So I haven't integrated yet, I've just simplified everything so I can integrate. So then you add 1 to the power, so you add 1 to 2 and you get minus 1, and you divide by the new power. Okay? Right? Here you add 1 to the power, which is 1 a half plus 1 is 3 over 2, and you divide by the new power, which is 3 over 2. So this will just be a minus and bring the x back downstairs, 1 all over x. Is that okay? Here we're dividing by 3 over 2. So it's x to the power of 3 over 2 divided by 3 over 2. So that means multiplied by 2 over 3. Is that okay if I jump ahead like that? So divided by 3 over 2 means multiplied by 2 over 3. Right? Okay. So that's minus 1 over x minus 2 times x to the power of 3 over 2 all over 3. Is that right? Plus c. Thank you. Forgot it again. Always. If I did my leaving cert tomorrow, I would lose marks for not having the plus c. Always. And when I did my leaving cert, I guarantee you I lost marks for not having the plus c. Right? I always forget it. Right? Is that okay? Right? So learn from my mistakes and don't forget it. Right? Are we okay? Can I do 3 part 3? Hopefully. Right? Can I go? I can go? Everyone okay? Right, okay. So 3 part 3 before I move on. So 3 part 3 is the integral of 4 root x. Thanks for not talking when I'm talking because it's all been recorded. Minus 3 times dx. So you need to write that as 4 times x to the power of a half minus 3. Okay, so then the 4 doesn't affect things. Add 1 to the power, so add 1 to a half, you get 3 over 2, and you divide by the new power, so you're dividing by 3 over 2. Okay, and then integrate 3 and you get 3x, and we have plus c. Yay. Right, okay, so here we want to divide by 3 over 2. So what does that mean? Divide by 3 over 2 means we're going to what? Multiply by 2 over 3. So that's multiplied by 2 over 3 minus 3x plus c. And that would be 8 times 8x to the power of 3 over 2 over 3 minus 3x plus c. We good with that?
Yeah, thank you.
Right. Everyone happy? Happy to move on? Right, okay. So the next section is finding the constant of integration. Okay, I have the heading written, okay, but don't bother writing the sentence. We'll go straight to an example then. Okay, so just write finding the constant. So we need to be given more information. Okay, so don't bother writing down that sentence. We need more information. Okay, because it's pretty obvious, right? So if you want to find out what C stands for, which number C stands for, they have to tell you more. Okay? So they have to tell you more, right, if they want you to know what C stands for. So finding the constant of integration is the heading. Don't bother writing down that sentence. Let's just go straight to example 1. Right? Find the constant of integration if the integral of that is 7 when x is 2. Right? Okay? So this is example 1. Right. Okay, so we want to integrate 6x squared minus 8x plus 5, and they tell me when you integrate it, the integral, when you integrate it, you can get 7. So is 7 when x is 2. Right. Can I go? Yeah. Okay. Right. Lovely. That's really straight. Yeah. Right. So we integrated first. I never said dx there, but there's a dx there at the end. That just means everything's in terms of x. So integrate. The 6 doesn't affect anything. Increase the power by 1 and divide by the new power. Right? The 8 doesn't affect anything, right? But you increase the power by 1 and you divide by the new power, right? And then a constant becomes a 5x, and we know there's a plus c there at the end, right? Okay, so simplifying that, that's 2x cubed minus 4x squared plus 5x plus c. Okay, so they're basically saying when x is 2, everywhere I see an x, put in a 2, and the answer is going to be what? 7. So it's 2 times 2 to be cubed minus 4 times 2 to be squared plus 5 times 2 plus c, and the answer is going to be 7. So 2 cubed is 8, that's 16, minus 16, they cancel each other out, that's 10. So c is equal to 7 minus 10. So c is equal to minus 3. So the original function was 2x cubed minus 4x squared plus 5x minus 3. Is that right? Happy with that? Okay. So you know the way they told me the answer was 7 when x is 2. Sometimes they'll tell me the original function went through the point 2, 7. So then you have x and y. Right, okay. So we'll do example 2. Example 2 is a bit harder. So remember, if the function is y equals, so y is the answer, right, okay, and the x's are here. So sometimes they tell you a point, right. So here, instead of y I put in 7, and instead of x I put in 2. So sometimes another way of phrasing that would, they'll tell you it went through the function, the original function went through the point 2, 7. Is that alright? Okay, are we okay with that? Right, example 2, it's a bit longer. Right, okay. Press the wrong button, sorry. Right, okay, so why is that too big? Sorry, I just need to, someone was, I'll make it smaller, sorry. Better, isn't it? Now, we're revising a bit of differentiation here because we have to remember what all these things were in differentiation. Okay. Okay, ready? No. Okay, girls, cast your minds back to differentiation and tell me what dy dx stands for. Dy dx is the same as what? Slope. Right, slope of the tangent, yeah? Is the same as the slope of the tangent at a point, okay? So what we do, what we have, is we have some sort of a curve, right, okay? We have a tangent, right, okay? They tell me the tangent is at 3, 6, so I know this point here is 3, 6. They tell me the tangent also passes through the origin, so 0, 0, right? And they tell me dy dx equals 2x plus k, so that's another way of telling me the slope of that line is equal to what? 2x plus k. Would you agree? That's another way of telling me the slope of the line is 2x plus k. But I can get the slope of the line another way, can't I? What could I do? Use the slope formula. Okay? So
How are you getting 2x plus k?
it's in the question. They're telling me dy dx equals 2x plus k. Right? So y2 minus y1 all over x2 minus x1 is another way of getting the slope. So I'll call this x1, y1, x2, y2. So that's 6 minus 0 all over 3 minus 0, which is 2. Am I right? Yeah. So 2 is the slope. But I also know they told me dy dx was 2x plus k. So I also know that 2x plus k is also the slope. Agreed? Right? Okay. But I know x at the point. Right? Okay. I know x at the point. It's the point at the point 3, 6. It's the slope of the tangent at the point 3, 6. So what can I do? Sorry? Lovely. That's exactly what I'm going to do. So 2 equals 2 times 3 plus k. And that means k is equal to 2 minus 6, which is minus 4.
Sorry, where's the 3 coming from?
It's the tangent, slope of the tangent at the point 3, 6. They told me that in the question. So x is 3 at that point. Okay? Is that alright? Are we all okay? Right? Okay. So now I figured out what k is. So now I want to know what the equation of the curve. So to get the equation of the curve, I'm going to integrate 2x, and we know k is minus 4. Okay? With respect to x. Okay? So if I integrate that, right, increase the power in the x by 1, divided by 2. Right? Minus 4 becomes minus 4x, and we have plus c. Is that alright? So y equals that. Okay, how will I figure out what c is? How will I figure out what c is? What do I know? Go back to the diagram. What do I know? What point is on the curve? 3, 6. Okay, so I know 3, 6 is on the curve. It's on the tangent, it's on the curve. So everywhere I see an x, put in a 3. Everywhere in y, I put in a 6. So you get 6 is equal to, I could simplify that, couldn't I? X squared, which is 3b squared, minus 4 times 3 plus c. Right, okay, so that means 3b squared is 9. 9 minus 12 is minus 3. And when it comes over, it becomes a plus 3. So I think I'll get 9. C is equal to 9. Is that okay? 3 squared, 9 minus 12 is minus 3. And when it comes over, it becomes a plus 3, and you get C is equal to 9. Right? So they want the equation of the curve. So the equation of the curve is y equals x squared minus 4x plus 9. Is that okay? Happy with that? Right, okay. I think we might need, I don't have any more examples of those, but I think we might need another couple of examples. What do you think? Right, okay. Or will I leave you do one? Will we do page 70, number 9? Let's do page 70, number 9 to start with. Page 70, number 9. Right, and I'll put it up here for those of you who had no books. Right. It's there now, is it? Can you read it? So if the integral of 6x plus 5 is 19, so when x is 2, so you integrate it, everywhere you see an x, put in a 2, and the answer is 19, you'll find out what c is. Done?
Yes.
Answer?
-3.
What's it?
-3.
-3, everyone in agreement? No one needs it done? Right, great. Now we'll do number 13. Remember, it talks about a turning point. What's the story of the turning point? dy dx equals 0. Right, so it talks about a turning point. dy dx equals 0.
And then you find the turning point from that, or that always confused me a lot. Turning point.
Turning point
Yeah.
means you have a point on the curve. So turning point, sorry, I know it's frozen. Right, okay. So it says the curve y equals f of x for which f dash, right, so they're telling you f dash of x equals 4x plus k. Right, okay. So we have a curve. A turning point is here. So it just means we have a point on the curve. Right, okay. And at the turning point, dy dx equals 0. That's the rule. dy dx equals 0. Right? But you have dy dx, don't you?
Yeah.
What is dy dx?
4x plus k.
Yeah, 4x plus k equals 0. You have x, because x is what?
-2.
Minus 2, get k. Right, okay. Right. And then integrate, find the coordinates of the point at which the curve meets the x. Integrate to find the curve. Integrate, fill in that point to find c, and then you have the curve, and then find out where it cuts the y-axis. Cuts y-axis, you let x equal 0.
Yeah. Okay. So after you get k, then you integrate.
Then you integrate,
So
yeah.
whatever value I get for k, it will be something x.
Yes, exactly. Yeah, sorry. It was number, what did I say? 13. Right, 13. It's too big, is it? Is that alright? Can you read that? 13, here. Sorry. Are we okay? Will I help? What happened there? Why did it stop recording? No, it didn't stop. It's fine. Okay, right. So basically, they told me, right, okay, here's the integrated dy dx, right, okay. I know the story that they told me the turning point was minus 2, 1, and I know that at this point dy dx equals 0. So I just need the x value. So all I do is fill in for x, 4 times minus 1 plus k equals 0. That's minus 8 plus k, sorry, it's blown up. Minus 8 plus k equals 0. So that means k is equal to 8. Okay? So that means, right, the integral, right, of the function, when we integrated or when we differentiated the function, we ended up with 4x plus 8. So what did we have before we differentiated the function? What was the equation of the curve? So you integrate that. So integrating that, so you want to integrate that, okay? So you 4x increase it, squared, divide by the new power, right? 8 becomes 8x, and then we have a plus c. So that's what the original curve looked like, f of x equals all of that, right? I can simplify that, going forward, equals 2x squared plus 8x plus c. But I know it went through the point minus 2, 1. So minus 2, 1 was useful twice, because it helped me find out k, and now it's going to help me find out c. Okay? So everywhere I see an x, put in a minus 2. Everywhere I see a y, put in a 1. So f of x is y. So 1 equals 2 times minus 2 to be squared plus 8 times minus 2 plus c. So that would be 1 equals, that's 8, isn't it? 2 times 4 is 8. Minus 16 plus c. 8 minus 16 is minus 8. When it comes over, it becomes plus 9.
Should there not be a minus 1?
Should there not be a what?
Minus 1? The question says, the point is minus 1. Yeah, the point is minus 1.
Is it?
Why?
Sorry, minus 2, minus 1?
Yeah.
Oh, sorry, minus 2, minus 1. So that should be minus 1. So that means c is equal to 8 minus, bring over, that's minus 8 plus 8, 7. Am I right now? Right, okay. So the curve, the original curve was f of x equals 2x squared plus 8x plus 7. And the question is, where does this cut the y-axis? Right, so what's the rule? Cuts the y-axis, what? X equals 0. Okay, so, I've no clean board, sorry. Wait, I find a duster. One would have a duster right here. So you write down cuts y-axis, y-axis, x is 0. Right, okay, so that's y is equal to 2 times 0 to be squared plus 8 times 0 plus 7. So y is equal to 7. So the answer is the point 0, 7. Happy with that? Okay? Are we all okay with that? Moving swiftly on? Yeah? Happy? Right. Okay, good, because that's as hard as they get. And there's a good bit of revision and differentiation in there, isn't there? Right? Lots of stuff came up there that will help us with our revision for differentiation. Okay, so the next thing we're going to learn to do is we're going to learn how to integrate exponential functions. And the good news is all these rules are on page 26. 26? So, yeah, I have written down 1, 2, 3 rules are all on page 26. Okay, so if you integrate e to the power of x by itself, just e to the power of x, you get e to the power of x. When we differentiated e to the power of x, we got e to the power of x. So it's the same forwards as backwards. Okay, plus c. Don't forget the plus c. Right. If there's a number in front of the x, as in e to the power of 3x, e to the power of 2x, e to the power of 5x, e to the power of minus x, okay? It's 1 over a, so whatever that number in front of x is, it's 1 over that, multiplied by e to the power of ax plus c. Okay? And then a to the power of x, a is any number, like 5 to the power of x, 2 to the power of x, something like that. Okay? You get, if it was 2 to the power of x, it would be, when you integrated it, 2 to the power of x over ln 2. Remember, ln is log to the base e. Right? Okay? Plus c. That's very noisy yawn.
Sorry.
Okay, somebody's tired. Right. It's called Blue Monday.
Yeah, exactly. Tired.
What time do you go to bed?
Like half 12?
Half what?
Half 12.
Oh my God.
Yeah.
I was halfway through my night's sleep at that stage.
I was very productive last night. I was on a run until about 10 o'clock.
Studying?
Yeah. No, I was on a run.
Oh, running, physically running.
Yeah. Not a study run, but I did go to study.
That's a bit gloaty now, Bo. Right. Okay, are we okay? This down? Right, examples. Right, just do example 1. Right, okay. Just do example 1 and then I'll do example 2. I'll answer it and then we'll do example 2, etc. and so on. Okay, so just write down example 1 and then I'll write down the rest of them as we go along. Right, okay, I presume we're ready. Have you done?
Yeah.
Right, so the integral of e to the power of 4x, and remember dx just means that everything's written in x. It's not, it has no bearing on anything. Right, okay, where's the remote? Where would one put one? Oh, I see it. Thank you. Okay, so when we integrate that, what do we get? You get, what do you get? 1 over 4 e to the power of 4x, and the rest? Plus c. Done. Okay, that's your answer. Is that alright? Okay, example 2 was integrate e to the power of 4x plus 5x dx. Okay, I could have picked a different e to the power of something, but again, that's 1 over 4. Integrate the first term is 1 over 4 e to the power of 4x. And integrate 5x, what you get? 5x squared over 2. And what do I need to stick on the end? Plus c. Okay, is that alright? Okay, next one. Going, gone. You all okay? Right, example 3 is the integral of e to the power minus x dx. So it's 1 over the number in front of x. What number is in front of x? Minus 1, isn't it? Right? So, and then it's e to the power minus x plus c. And remember, 1 over minus 1 is just minus 1 or minus e to the power minus x plus c. Is that okay? Right. Just be careful with that one so people forget it. Right? Okay. So it's 1 over, you treat that as minus 1. Okay? Right. And the last one is example 4. Example 4, we have the integral of 6 to the power of x dx. Okay, so that's just not e anymore. And the rule for that was it's 6 to the power of x divided by ln 6. And it's, as I say, it's written in the log tables. You don't even have to remember it, but you do have to remember to put on the c at the end. Done. Right, is that alright? Okay, right, yeah, done. 42. Yeah? Do you want to do a few for 3 minutes? Is that a no? Or is it a yeah?
It's a no.
It's a no.
Well, like, if you want to